And we're live on BIM Broadcast. Welcome everybody to another BIM Broadcast show. We're joined once again by Buck Davis and Anthony Remus from BIMBOX. We're going to be talking today again about computer hardware. And today's focus is going to be primarily discussing hard drives. Well, not hard drives, that's a wrong term. It's computer storage, I suppose, because hard drives are a specific kind of computer storage. We're going to get into that a little later though. So Buck, Anthony, welcome to the show.
Hey, happy to be on, man. Happy Friday.
Happy Friday to you as well. So we talked already about overall computer performance. We've talked about RAM. We've talked about processors. And today the discussion is going to be on hard drives. Last time when we were talking about RAM, we were mentioning that hard drives were actually one of the biggest bottlenecks. Just before the show, we were kind of side talking here and getting ready for the show, and Buck, you kind of made a correction to that. Hard drives aren't technically, well, computer storage isn't technically the bottleneck necessarily. It's really the motherboard, right?
Right. The motherboard is, and you know, they always just say, you know, we get the politicians we deserve. We get the speed we deserve, right? I think motherboards right now, we can put more drives in them than they can actually handle controlling the data to and from the CPU. And that's dictated by the consumer, right? Most people don't look at drives as a big deal. Not many people could tell you the IOPS on the drive they're using right now, or the performance specs on the model. They can tell you I got a Titan X, or I got a 2080, or something along those lines, but they can't tell you anything about their drive, which is why my conclusion is that motherboard manufacturers, this isn't a hot point for people. You know, so they put what's in there. The consumer products right now run well on it, but I'm a drive nut, man. We have stacked many drives. I think one of the first motherboards I bought from ASRock was an Extreme 11, and that was because it allowed you to put 21 solid state drives in a RAID 0, which was the first time I got really geeked out about drives. And I think that this is going to be a really interesting session this week, because drives are the most important thing in my book that you can put in your computer.
Right. So we're going to cover a couple of things today. We're going to talk about the difference between mechanical drives and solid states. And solid states are kind of a generic term. There's all kinds of variations on solid states. We're going to talk about that as well. I know every single time I mention like a standard hard drive, like a mechanical hard drive, Anthony like dies a little inside. And so we're going to have to kind of stop talking about those pretty quickly here so that he can stay on the show. We're going to talk about explaining a little bit about that bottleneck that you were talking about, and where that really comes from, and kind of explaining the processor to RAM to hard drive communication, since we're tying it all together today. We're going to talk a little bit about that. And then at the very end of the show, we're going to touch a little bit on something that Buck, you and I are going to be working on here very soon, I believe, which is talking about RAM drives and how that can potentially affect your performance as well, and what that really means, so that people can have an idea of what's potentially coming down the line.
Right.
So first of all, let's start by discussing different kinds of hard drives. So mechanical versus solid state, and then also the combination of rating. And so what's the major difference here? Why do I want an SSD over mechanical? Why do I want a RAID? What is all this?
Anthony, I'll let you kick that off.
Yeah, so I guess just going through the basic forms right now. Typically, most of your computers are going to ship with an actual spinning drive. Yep. So that's like a 3.5-inch drive. Laptops, 2.5-inch drives. And that's basically the size of the actual platter inside. So a 2.5-inch drive, even if it is a 7,200 RPM drive, will be slower than a 3.5-inch, just because the outside diameter is spinning slower, just you know, mechanically size-wise. There's really good drives now that are doing about 220 megabytes per second, or megabits per second, or megabytes per second. But once you step into SSDs, now all of a sudden you're in the 500 range. The difference though, the main speed you're going to get going from a mechanical to an SSD is going to be in your small files, the latency reduction, how many inputs and outputs it could take in at, IOPS is inputs, outputs per second. So the drive can actually do a lot more at the same time. That's why going from a mechanical to an SSD, it's like night and day. It's enormous. And I think most of the users here are probably on SSDs already. Going from an hopefully, going from an SSD to an NVMe drive, I mean, the difference is actually in the protocol. NVMe is non-volatile memory. I forget what the EOE stands for, but basically it's just a different protocol. Sure. Your normal SSDs are only capable. They were designed on the protocol that the spinning drives are based off of. So once you get into an NVMe drive.
Yeah. So the real difference between spinning and SSD is that you have the mechanical solid drive sitting there. It's not solid state, but it's a solid drive. And the reason why it's slower is that you have to spin up a drive mechanically. You have to have this reading arm go find what it's looking for on a spinning drive.
Correct.
Whereas an SSD, you're more instantaneously able to go access it just by the address of the data.
Yeah, you basically have a memory controller that can access the memory modules, multiple of at the same time. The better the memory controller, the more actual memory modules it can read from at the same time. So that's where you start getting these boosts in IOPS. The cool thing when you step into NVMe drives, it actually has less CPU overhead. So meaning the CPU needs to work less to access more data. That's one of the big advantages with NVMe drives. And it's not like, well, hey, I got a $1,000 CPU. I'm not worried about CPU overhead. Let's say you actually try to do an experiment and you try to read 10 gigabytes per second. You would max out a 10-core processor. Even on NVMe drives, it would take basically the whole CPU's compute power to read 10 gigs a second. If you're literally trying to break 10 gigs, you'll find that it's actually, you need more cores at that point. And then that's where Buck gets into it, where the motherboard is the limitation, because you figure most motherboards won't have the ports for that.
So but Buck, let's talk a little bit about that. Since Anthony just brought that up, let's talk about why the motherboard's actually the bottleneck. Last week we did say, and we kind of talked a little bit about it earlier, that the hard drive was the bottleneck, but it's not.
Well, there are a couple different steps to this, and I think this is important because we've looked at some different technologies that can help speed this up. So when I say the motherboard is a bottleneck, when a motherboard manufacturer creates a motherboard, they have to figure out how they want to disperse the lanes to the CPU. If you look at a 9900K or you look at an X299 or even an AMD board, there'll be a number of PCIe lanes that can go to the processor. Some of the things that we look at, we see that with graphics cards. If you want to put 3 graphics cards in a motherboard, they all might have X16 slots, which is full X16 bandwidth, 16 lanes to the CPU. But once you start stacking cards in there, you might be getting X8 on the first one, X4 on the second, and X8 on the third. That kind of comes from the fact that the motherboard manufacturer doesn't know how many things you're going to put in there. And at some point, if you load it up, it has to make a decision on how that's going to get there. So it's no different with the drives, right? They know that you might put an NVMe drive in, which really can almost tap out an X4 slot. So if you put 3 or 4, NVMe drives and then put drives in the PCIe slots, how's that data getting to the processor, and how does it limit what's going on? So the motherboard is a hurdle as far as if we put 3 or 4 Optane drives, one of the Intel PCIe drives in there, we tap out bandwidth to the CPU. We can actually put more drives in array, which we'll talk about a little bit, that can go faster. They can read and write faster than the data can actually get to the processor.
So
when we talk about I/O, yeah.
This is a lot like the infrastructure of a city then, right? Like this is like a freeway. You've got 2 different cities. One's the processor, one's the hard drive, and actually RAM's involved in this as well. And you have to get the vehicles, the data, the bits of information from one to the other. And if you don't have enough lanes, if you don't have enough bandwidth, you're not going to get there very quickly. You're going to end up with traffic jams. And that's true of data just as well as it is in our cities.
Yeah, and then it gets, once we get off the hardware side, we get to the software side of things. And I want to give Kelly Cohn a little shout out because he's one of the first people to really bring this to my attention. Once we hit the software side of things, right? So the data has gotten to the processor has gotten it through the OS. The operating system has I/O patterns, input outputs of how data can come through the operating system, how fast it processes, and then actual programs. We're AEC podcast. There are certain programs that have really, really efficient methods of I/O. Navisworks is a great example of that, right? So, Revit's one where if we put the fastest drive in the world, and we've tried this, we've done crazy raids with Revit, you hit a limitation inside of Revit. Navisworks is one of those programs, as fast as you can get that data to Navis can crunch it and get processed extremely fast. So there are a couple bottlenecks on the way, motherboard being one, drive being one, CPU being one, and then in the end, Windows and the software become their own little bottleneck. So there's a lot of stuff we got to deal with in this process. Some of that stuff we can control and some we can't. But today we're going to be talking about the hardware side, which is really where we can make an impact.
Right. I guess to touch on it, the seat of your pants, like the number, if you start benchmarking drives, the one that you feel when you start opening and clicking on things, that's going to be your smaller, your 4 kilobytes and the ability for the drive to really handle IOPS and small files. And then when you're doing transfers or opening really large files, that's where that throughput comes in, where manufacturers will advertise that 3 gigabytes a second or whatnot.
Right. So we can get the data to the room faster, and that can get to the processor hopefully faster. So
we didn't touch on Optane drives either. Which is actually my favorite form of drive right now. It just happens to be the most expensive consumer drives, and it's basically an Intel developed drive. So you'll see some sort. I mean, it'll work on AMD, but basically only Intel's making them right now, and those have blazing fast. Like their IOPS are awesome. I mean, their ability to open and close small files, it's like 3 to 4 times as fast as an Nvme drive.
Nice.
And the problem was they kind of snuck up on us because when they first came out, they had great latency, but their throughput was only like 500 megabytes per second. And now Intel with the 900 and the 905P series, they've really like stepped it up where you'll take a small hit where you'll get 2.5 gigs a second versus maybe 3.5 gigs a second on the throughput, but you're getting easily 3 times the faster response with smaller files. You'll get like 200 and something megabytes per second on small files versus 60 or even 40, right. And versus on an NVMe. So
nice. So let's talk about raiding a little bit. I used to play World of Warcraft. I know about how to raid in a dungeon, but that's not at all what we're talking about here. This is a whole different world. So you're talking about raiding. You're taking multiple hard drives or multiple drives, and you're pairing them together in a way that makes them more efficient, either more volume or faster or what have you. So tell me about RAID, Buck.
So RAID came about, back in the day when they were spinning drives. Right? We IT managers will know a lot about this. If you talk to your IT manager, they'll probably be a RAID nut, or at least say there's certain RAIDs they don't do. Which my favorite is a 0, which they'll tell you they're not going to do. The idea was
that's for server side, right?
Yeah. Or on the server side, well, it depends on what you're trying to do with a RAID, right? So we were limited to spinning drives, and you have a drive nut. How do we make things go faster? What we can do in a RAID is it's a redundant array of independent drives. Or if you're doing a RAID 0, I would call it a rapid array of independent drives. So you're making 4 drives or 5 drives or whatever the number of drives you are work together as one drive. So the computer is looking at all these multiple drives as a single drive. And then you dictate how data moves to it. So a RAID 0, which is the rapid, the fast way, is you're saying all 4 of these drives write blocks of data to them sequentially. So it's almost like, if I was sitting here writing down and you were yelling A, B, C, D, E, F, G, I had to write A, I had to write B, but if you could say, okay, Buck, I'm going to hit you with A, Anthony, I'm going to hit you with B, Buck, C, D, we'd be raiding twice as fast. So if you put 2 RAIDs, two drives in a RAID 0, we're doubling the speed of that drive. If you put them in a RAID 1, which is more often likely than what you're going to hear IT manager or server, RAID 1 is we're putting 2 drives and they're going to have the exact same information on both. The real difference there is you're getting redundancy. And the reason that's important, and I think we want to stress that, that's one thing that BIMBOX we're starting to stress to all our clients is, what is a down day worth for you? Because look, drives break. Every now and then it just happens. And I think we've all had that day where you turn up and Windows says, you know, something wrong with the driver, it's corrupted or it doesn't work, and all your data is gone. In a RAID 1, it'll pop up and say, one of your drives has stopped working. But that's okay because the information is on the other drive. Please replace the damaged drive. And when you put the replaced drive in, it copies it back 1. So RAID 1 is interesting. And then there's also a RAID 5, 6, and a 10. A lot of people like 10 because it gets you the speed of a RAID 0 with redundancy of a RAID 1. The problem with this is now we're looking at how many drives we want to buy. Like Anthony says, our favorite thing to do is RAID 3 M.2 drives. If we want to do a RAID 10 for that form, we'd have to have 6 drives. You'd have to have 3 and 3 over here. And there's some really interesting charts you can look at. And if you Google crazy RAID arrays, there's some really, you'll see some drive nuts holding up a cord with, 20-something drives talking about they're getting, 15 gigabytes per second. A lot of this was back in the day when solid state drives first came out. People started geeking out on this. But once you get into a RAID, you're kind of limited by either the software RAID or a hardware RAID. A software RAID is done on your computer. You put 2 drives in there, you make it 1 drive, you're going really fast. You take those 2 drives out of that computer and put it in another computer, and your data is gone, right? Your computer holds the key to how that data is configured. There are also hardware RAIDs, which the RAID drive that we gave out last week is a true hardware RAID. You can take that drive out of your computer and put it in any other computer, and it's just like putting in another drive. That data is succinct. That drive knows how to communicate with that. Yeah. So depending upon what people are trying to do, I would like to say drives are cheap enough right now or affordable enough right now that everyone should have a RAID 1 on their computer. Any professional AEC person that cares about not wasting a day of downtime, which, a day of downtime, most people's billables, you're probably in the $80 to $100 range. We're talking about, close to $1,600 a day. If a drive is $250, it just seems to make sense to go and put an extra one in. For our point cloud processing people and laser scan processing people that are having to crunch as much data as possible, this is where we would say have a drive that's a RAID 0, where you're crunching the data, and then also have another drive over here where you're archiving the data, right? So when you're working on something, this is your favorite RAID. But it's you have to be disciplined when you do this. I will tell you, we've told people do not store things on RAID 0. The drive that we sent out has 4 drives in there. So if any one of those drives goes bad, you're done. And there are some
on a RAID 0, correct.
Yeah, you don't want to wake up with lots of data that you have stored on a RAID drive and have that. It's a sad day. It is an extremely sad day because then you're trying to figure out which one of the drives is bad. So it's powerful and it can also be dangerous. I think it's the use case that we look for that really dictates that. And I think RAID is one of those things that's been around for a while, and it was really made for slow spinning drives. And now that we have all these crazy fast drives, you can really get a big boost on it. It's one of the places that it's not really seen that you can get a big jump on it. I mean, Anthony, you've done testing with Revit benchmarks and other things that, we just hit a wall, right? I mean, I think we put 2 or 3 octane drives, like almost $3,000 worth of drives in a computer, and it wasn't that big of an impact because, one, I think the software just couldn't handle that bandwidth because not many people have that bandwidth. Autodesk is not writing software code for people that can go 5 gigabytes a second when most people have an SSD in their computer.
Right.
So
like for example, I mentioned Optane drives. They blow NVMe drives away, but I mean Excel is still going to only open so fast. Like it's weird because it's like this drive is 3 times faster than my last one, but Excel is opening about the same, and that comes into play where it's like the OS and the software. It's only leveraged to use so much of your hardware.
Right.
So it really depends on what you're doing.
It's supposed to open off the hard drive, go through the processor and get cached into RAM for its running ability. So you're still going on 3 different jumps. And in some cases, depending on the tool, it might even have to paint on your screen, right? So your graphics card may come into play. So,
Yep.
and all of this has to go on that same freeway.
And this is why one thing that I'm a nut about is motherboards. I'm a CPU nut and a motherboard nut. Buck's a storage nut, but it's actually when you start thinking about all the things that are going on at the same time. Not to take away from the SSD conversation, all of that plugs into your motherboard. Do you really want to trust all of this to like $150 motherboard? And that's the difference with systems that we're building. We'll gladly open up and show people what motherboards we're using because we're not using the cheapest boards we could get our hands on. We're trying to get the right boards because, man, all of that, the way that these engineers will map out the traces that everything's communicating on could even affect the speed of your drives.
Right.
Talking about RAID though,
if you've never had the ability to do this, if you're at a show and you see BIMBOXes out there someplace, look at inside the case. The inside of their cases are sexy. Just saying, they look great.
Thanks.
Anthony does wonderful.
Cool, man.
Yeah.
Aaron probably took the coolest looking one from us though. The one that had the dual radiators and everything was liquid cooled. But that'd take too long to manufacture.
Yeah.
Yep.
Yeah. But I'm talking about RAID also and the relationship with the CPU bottleneck. If you want to get in on this, you have to be mindful of the CPU you're running. Like for example, right now I'm streaming from my personal system. I have 2 RAID arrays in my system, an NVMe RAID and an SSD RAID. The NVMe RAID is bottlenecked by the PCIe bandwidth. So I'm RAID zeroing to gain capacity, not speed.
Sure.
I'm still at 3.5 gigs a second, but now instead of having 2 500 gig NVMe drives, I have a 1 terabyte essential device for my OS. Whereas my SSDs, though, instead of being 500 gigs a second, now I'm closer to 1 gig a second. So just because you're RAID zeroing, it doesn't always mean you're going to get a speed improvement. Sometimes you just do it for capacity.
Yep. So you're not having to buy a terabyte NVMe drive. You're buying 2 500 gig NVMe drives, which is probably substantially less expensive.
Well, because what do you do if you need a 4 terabyte OS drive? There's no 4 terabyte NVMe drives, so the solution would be to RAID 0, or RAID 10 would be like the safest, but that's one workaround for now.
Right. And that again,
Shawn,
go back to that discussion about RAID. That's why you were saying that IT managers don't RAID 0, right? It's volatile. One drive goes bad, your whole drive is bad, and that's not good for servers, right? The whole goal with servers is redundancy, and so with the RAID 10, you can take 3 drives and make it RAID 0. You can take another 3 drives RAID 0, and you add them together. It's like RAID 1 and RAID 0. That's why it's RAID 10, right? Like that's my theory of it.
Yeah. Off the top of my head, I think RAID 10 requires 4 drives. So you could lose 1 drive, and then if you have 6, then maybe you could lose 2. It goes on from there, but but for client stuff, unless we do a proper RAID array with hardware, I kind of shy away from it. That's why Buck has that RAID card we use.
Sure.
Well, and Shawn, just to tell you, this is a secret that I have not shared with Anthony because before Anthony came on board as a kind of head of product and whatnot, I had reached out. This is when I was going through my deep drive nut phase, and I was like, there has to be a way. I'm talking to Kelly Cohn every 2 days about RAID cards and sending him stuff. And there's a company out there that we found that does data tiering and I/O optimization. So they worked with NASA. NASA was trying to figure out how to get data fast from the ground to a satellite or a station in space, and lots of data. And this is back when spinning drives. So this company, and we don't ever bring it up to clients, honestly, because the first time I ever pitched it to a client, they're like, and it cost $5,000 for what? Right? We have the ability to do it. I changed it from Windows Server because they actually use it on server data centers right now. It throws out Windows input-output patterns and puts new input-output patterns in, where you get 80% more efficiency from your CPU through the data throughput. And then there's tiering. So when we say, IT managers don't want to do tiering. This is really getting to drive that stage. They would allow you to set different levels of cache, right? So we're going to talk a little about RAM drives, but imagine this. So anybody that uses crazy amounts of data, imagine 4 different levels of data, right? So we're going to have our fastest data on our RAM. Then we're going to have a crazy RAID 0 right here, which will be the next level of cache. Then we're going to have a huge spinning volume of 8 terabytes. And then we're going to have some cloud storage, and there's going to be some logic. So the data we're using immediately will be sitting on RAM. Then we'll have, depending upon the size, a 2 terabyte or 3 terabyte, really, really fast RAID. That will keep the next relevant, most used data there. And then we'll have this local drive that's maybe 15 terabytes that's just keeping everything else. And then the cloud, if we get over 15 terabytes, we'll just start saving stuff off to there. It'll show up as one drive. But data centers do that all the time because they might have, 10,000 spinning drives in some form of RAID, storing all your Facebook data. And then they need to keep the more relevant stuff on these Fusion IO Optane drives, which is really where Intel sells these high volume Optane drives, is to Facebook, to Microsoft, to Google, to accelerate the data that is being most used. And then RAM, because you just run out of capacity of RAM and it's extremely expensive being tiered. So for people that want super fast Windows IO, crazy tiering of drives on your desktop, it's available. It's just, once again, how big of a problem is it for you? And we have that, and we've convinced them to create it for Windows 10. And I actually have a couple licenses here, Anthony. I haven't wanted to share it with you because once we do those results, you're going to be in the same mode I am. Like, why doesn't anyone want this? But, $5,000 more on a system. And that's not us. That's a licensing fee. That is cost. We do not mark it up. If someone wants it, it is just coming to you. But that's where you get into the tiering and thinking about how data is stored, what you need really locally, how much you need locally. And one of the things that Anthony brought up is capacity versus capacity versus speed. A lot of people say, well, I have a 2 terabyte drive. I need a 2 terabyte drive. I'd be hard pressed to say, and I was at Balfour Beatty, I had 3 different versions of Revit, 3 different versions of Navisworks, 2 different versions of AutoCAD. I had Fuser, I had Inkscape. I had 15 project folders saved on my 512 gigabyte 970 Pro, and then I had its sync folder going to my cloud storage. So I put in another 2 terabyte drive that was just emulating a folder in the cloud. So that was data I didn't need immediately, but I'm not pulling from the cloud all the time, going through the internet. I could keep everything there. So when you think about, do I want to spend an Optane drive with a 480 gigabyte is about $600. The same 500 gigabyte 970 Pro might be $250. So maybe instead of getting a terabyte, which would be $400 or $500 more, maybe I go with that Intel drive at a 480, and then I just buy an archiving 2 terabyte drive, to be there.
Yep.
So really be mindful of how much storage you need because there is a cost to this stuff.
And that is how I used to set up my old laptops before I got this BIMBOX that we're broadcasting on today. Is I had a solid state drive for my main OS and where I would put most of my important stuff that I wanted fast, and then all of my just bulk storage and support files and garbage went off to that spinning 2.5-inch SSD or hard drive, because it doesn't need to be that fast, but I needed the capacity. So same kind of concept.
Yeah.
And it was
so you are running a RAID 0, I forgot.
Yes, I am. Yep.
Nice. Living dangerous.
Hey, it's fast.
Hey, with good backup.
Is so fast.
With a good backup, though, regimen, I mean, it's not that bad.
No.
I mean, did you kind of want to just get into the practical aspect instead of just spitting out a bunch of info and just talk about what's currently out?
Yep.
So, so basically, like, let's say you were to purchase a modern workstation, high-end workstation, you're going to have the option, like we just talked about, Optane. But just to kind of let people know, like, essentially Samsung's the king of NVMe right now. There's other companies that are doing it really good also, but because they're in control of everything, they're like, to my knowledge, they're the only company that's manufacturing every aspect of it. They're making their own NAND modules, their memory controllers, the PCB. Right. They're able to just fine-tune them so well that really, if you only need to know one brand, just get a Samsung NVMe drive. But to explain, right now we have the 970 Pro, and they just updated the Evo to the Evo Plus. I just want to let people know the main difference between the two. The Pro is an MLC drive, so it's writing less data per cell, than the Evo series, you'll get longer life out of that. Right. You'll get longer life out of that drive. The other thing you pay for when you get a Pro drive is that it's actually capable of writing its advertised speeds from start to finish, whereas the 970 Evo and Evo Plus depends on caching. So it'll cache, and then once that runs out of cache, it'll start to slow down. It doesn't slow down as bad as a normal SSD, but you're gonna get speeds that fall off. That's something to be mindful when you're shopping for normal SSDs as well too. Brands that are less reputable will sometimes they'll launch a new product with a good memory controller that can cache and write to the drive quickly, and then mid-life cycle they'll downgrade the drive, and once you run out of that cache, it can actually be as slow as a spinning drive. So when you start comparing drives when you're building your own system or buying one from someone, keep in mind there's cheap SSDs for a reason. They'll depend more heavily on caching. And if you're just dealing with small files, that's not a bad thing. You just got to actually analyze your workload.
Right.
Yeah.
So is this a good chance for us to jump over and talk about RAM drives a little bit and cache?
Yeah. Yes.
Yeah, I would say so.
So the general concept here is processor pulls stuff in and it's chunking through information, and when it runs out of its own like built-in internal cache, it's going to push off to RAM. At some point, some of this becomes what?
Like dormant.
The RAM decides it's going to jump into hard drive cache. When does that happen?
So that'll either happen when you start running out of RAM, or the system will recognize like this is a low priority storage, and it'll kick it over to page file. You're always going to have stuff in page file, even if you have 128 gigs of RAM and you're only using 8 gigs. So the system's kind of just determining the priority, like, and it's really good at predicting this stuff. So it's nothing you need to worry about. So that's when you hit page file.
Specifically, page files are very heavily used. So it's
that
like
wouldn't be good though.
it's taken like entire models and opening them up into page file, and on your hard drive, on your storage solution, it's opening up, you know, I think the ratio that I last recall was it unzips the Revit model at a 4:1 ratio. So what you see on the hard disk size as a stored file size, it unzips that 4 times, and then it opens up to the nearest 8-bit format. So, you know, 1 gig, 2 gig, 4 gig, whatever that number happens to be for the size of your file unzipped. That's a lot of space. That's a lot of information that it has to pass from processor to RAM back to hard drive constantly to get access to this information. And there's other things for the program as well that get put in this page file if memory serves.
Yeah.
So, well,
you know, one of the things that we want to talk about, I think, for this, when we talk about cache and we talk about, you know, RAM and how it works with a hard drive, I think for the people listening, one of the biggest use cases where you might have unseen performance drops is a lot of our clients, a lot of people that call us are saying, I'm using my laptop to process laser scan files. Okay. I don't think, I mean, I understand there's situations where you just have to be mobile and you have to have a laptop. And we always talk about right now, a lot of these programs are getting optimized for high core count. So a laptop does not offer high core count. But the place where you're really seeing a performance drop on a laptop comes down to the RAM and the drive, right? So first of all, you're going to get some thermal throttling on your 8-core or 6-core processors in a laptop due to heat. There's just not adequate cooling. But the other thing is most people in their laptop, very few people have 64 gigabytes of RAM in their laptop. They have 32 gigs of RAM. When you're processing those laser scanning files, all of a sudden you start tapping out your RAM. And then it's going to start using your solid state drive as the caching solution, just like RAM, a replacement for RAM. And that's where you see Recap Pro or Leica snail crawl. And you don't really see it because most people that are processing point clouds on their laptop hit process or register and then walk away. And then 15 hours later, they get there. It might have been trucking along real fast for the first 30 minutes or 45 minutes and then tapped out RAM. And now it's reading and writing using your solid state drive as RAM, and everything called to a snail. One of the reasons laptops aren't the great choice for point cloud processing comes down to, you know, the ability for RAM. So we can't put the same volume capacity of RAM on a laptop chipset. It's just not there. Anytime we talk to people that are doing serious professional point cloud processing, we say get 128 gigs of RAM and the fastest drive possible. Because we do see a lot of people tapping out 128. I mean, when you're on a data center or you're on a big, trying to think, I'm ready for it, on a stadium project, and you're crunching scans all day long, you are tapping out RAM, and this is where all of a sudden, now you're using your solid state drive for RAM, and everything snail crawls. I mean, RAM's 120 to 200 times faster than your solid state drive. That's where that bottleneck is. And if you don't know it, you just say it's going slow, I'm on a laptop. When in reality, you're tapping out your resources, right? So there are two different ways to look at the cache. In some instances, your solid state drive, in the worst instance, you run out of RAM and now your cache is being used on your solid state drive, right? That's terrible. That's a bad instance. And then, Shawn, what we're kind of alluding to on the RAM drive is, what if you had extra RAM, right? What if we wanted to make a RAM drive? And this has been around for a long time. And if a RAID 0, but if a RAID 0 gives your IT manager conniptions, the only thing that will give them more problems is saying, I want to make a RAM drive. The reason being is RAM only is holding memory when there's power to the system, right? So imagine.
Please use a UPS.
Yeah. So all of a sudden you run out of. Yeah. So the power goes out in your building, your computer shuts off, a RAM drive disappears. If you want to think about it, and there are lots of programs out there that do this. So some people have extra RAM. If you have 64 gigs of RAM, you're only using 20. You can create a virtual drive where your computer allocates a portion of your RAM, which you dictate, 5 gigabytes, 6 gigabytes, to create this virtual drive that sits right next to your CPU, where you can choose which files go to it. So now imagine, hey, this big Revit model, I don't want it to read from the solid state drive. I want that sitting on RAM next to my processor, right? That data is accessible almost instantaneously by the CPU, but we run into that problem once again. If power goes out, there's no backup to that. Right. There are a couple instances, and I think we're working on some right now that do give you a little redundancy. But when you think about that, that is the fastest form of drive we have right now. We've actually used a couple in-house solutions where we made a modified RAM drive. We used a caching solution. So we added RAM in the same sense you would the RAM drive to be the cache for your solid state drive, right? So most solid state drives, Nvme drives, have a couple hundred megabytes of cache. What if we could put 10 gigabytes of RAM to serve as the cache for the solid state drive? So the most used 10 gigabytes of data are just sitting next to the processor, and it's constantly reading and writing back to your solid state drive. So now we have this nirvana world of all the data I use often is sitting right next to the processor. And my fast Nvme drive is just sitting there waiting, storing the data. Every time there's a change, every 2 seconds, it's writing back. And that really, it gets cool. The first time I heard about RAM drives, I made one. I tried to install Revit on it, and didn't get any performance gain. So there's a little trick, and I'm not going to go any farther than that, but I think we have some cool solutions down the road that potentially will accelerate Revit via RAM.
Yeah, to keep in mind.
Yeah, go ahead, Anthony.
I just want to put it in a perspective where I mentioned writing 10 gigs a second to NVMe. An NVMe RAID requires a ton of CPU power. You could write 40 gigs a second to RAM with low CPU overhead because the memory controller is in control of all of the writing and reading and stuff. So you're just going next level. Like, I mean, 40 gigs a second, we're a long ways away from getting SSDs or NVMe's there. So there's a lot of power in a RAM drive. Yeah. So, I mean, just to put that into perspective.
So let's bring this back down to earth again. If I'm using a RAM drive, there's a couple of major benefits. My CPU has to work less, meaning it runs cooler and faster. It writes faster for less power directly to RAM. I'm not needing to go across the bus to get to the hard drive and to the RAM. I'm going direct to RAM and back, which is the fastest. It's, what do you say, 40 times faster? Is that what I heard?
Probably closer to 100.
Wait.
100 times faster.
Yeah,
give or
to
take.
cache. Yeah, cache. Yeah.
So significantly faster on these RAM drives, and what you're sacrificing is a bit of the RAM that you have installed, which costs less than a solid, Optane drive to put in there. It costs less. You can put more in, not in a laptop quite as much. You can max at 32, but you can still allocate some of that and get performance gains when it's tuned properly, because processor runs faster, cooler. You're going direct to RAM, which is significantly faster, and back to processor, and you're completely skipping the hard drive for that main process. And yes, you have to have that redundancy that goes back to the hard drive, but man, you have the potential to like boot into lightning speed. Your computer can go plat.
The downside to traditional RAM caching is the OS, it's software based, so you need to boot to your desktop, and then once the software boots up, and then it'll create the RAM cache drive, but once that RAM cache drive is created, it's essentially Windows sees it as a drive.
Right.
So it'll depend on the software to know how to use it, depending on how you want it used. But there's a lot of cool tricks. I mean, it's definitely something a lot of people have ignored for a long time.
Right, and to be clear, again, RAM, Buck mentioned this earlier, but I want to be crystal clear about this. When you shut the power off on your computer, your RAM is cleared. Like, it's done, it's gone.
Correct.
That drive doesn't exist anymore,
Correct.
Which is why you were saying, like, power goes out, you lose your data.
You're done.
Use a UPS, right? Like, make sure you've got this information able to be accessed. But it's a software solution that makes everything run faster if tuned properly, if the software can use it.
And there are RAM drive solutions out there that do save an image of themselves when you shut down your computer. Right. So I can go create a drive, and I always like to call it the R drive, my RAM drive, just to remember that that's what it is. When I close out Windows, it saves an image of that. When you load Windows up next time, it's going to load that image back into RAM. I used to use this in the AEC. I'm trying to think of a good use case. Anytime I had really, really big Navisworks models that had point clouds in them, I would make a copy of it, put it in my RAM drive, open it, and work from there, and then I would copy it back over to the archive folder. Or another one was when I was working on really big InfoWorks models. I know that anyone that has done a really, really big InfoWorks model, I mean, with multiple, Revit models, with a bunch of FBX files, with some scan files. I mean, I had 5,000 trees I placed for a university presentation. It just takes forever to open it up. So I would copy my InfoWorks journal into there and then make the direction, have InfoWorks look to my RAM drive, and that file would open up almost instantaneously. Just have to remember when you're done working in InfoWorks and you close out to copy that file back to the InfoWorks location. Just make a copy, even if there's an image file. But it made working with the file so much more pleasurable because everything's instantaneous. When you make a modification, it would happen instantaneously, as opposed to hitting save and seeing the spinning file, waiting, saving. It happens almost instantaneous. So if you want to check it out, download Google RAM drive, get a free trial, create a drive, put a huge Navisworks model on it, go to Navis and open it from that drive, and it will almost just pop up instantaneously.
Right.
Yeah, and that's where the software matters, because depending on the RAM drive software developer, they may have different caching features or auto saving features, and that others might not.
Yep. Now I know we tangented a bit today into RAM, but we're talking about computer storage and the access to that storage, and that's kind of why we did this little bit of a tangent. RAM is not storage per se. It's not per se. It's not storage. It's substituting for your storage while your computer is powered on. And it can give you some
It's a temporary storage.
Temporary storage.
It's not a storage, but it's not a traditional storage drive, yeah, for sure.
Right.
When you want to go fast in the drive world, RAM is going to come into it. Side note, when I was geeking out, and this is kind of cool, Anthony, you're going to laugh when I say this. So when you get into drive storage and RAM drives, you start thinking of, wow, I just need the fastest RAM imaginably possible to make my RAM drive one. And the fastest RAM available is not for computers, they're for graphics cards. HMV2 RAM is the fastest RAM. Those are on a lot of the RTX cards. So you start Googling and you start trying to figure out how do we leverage GPU RAM for RAM drive. And there's this Russian hacker that posted on Reddit, and he actually made a program where you could spin up a virtual RAM drive on your GPU. You don't get any use to your GPU.
That is cool.
That is pretty sweet.
Yeah.
That's pretty sweet.
What would be the one limitation? You know, when you go to these wormholes and you pop up and you're like, oh, why is it not doing what you think it would? It comes to the fact that it's a PCI Express. It has to go through the PCI slot. So we were tapping it out, but it was ludicrously fast for a moment. So that's kind of when you go to wormholes. Sometimes I have to remember what I'm trying to do up front.
Yeah.
Did it break 100 gigs a second, or? But did you see any benchmarks bug?
Yeah, you run into the bus limitation, but it was lightning fast.
Yeah, it's not only that. I mean, it's faster than DDR6 RAM, and we're on DDR4 for our CPUs. I mean, it's probably writing at over 100 gigs a second, I would guess. Like that's insane. Yeah. We'll see. I don't know, but yeah, that's pretty cool. Get a 2080 Ti, you have 11 gigs.
Right.
We've looked into this, and this is why I hope anyone listening to this will fall in love with drives to give us a reason to do it. We talked to the manufacturer that we had build those RAID cards for us, and immediately when we started talking about this, it's like, well, why can't we add 25 gigabytes of HMB2 RAM onto our RAID card to serve as cache for our RAID? And you can, they'll do it. And if we have 1,000 people out there that want to do this with us, we will go on and make the order. But once again, we get people calling and saying, well, I just want an SSD. And we try to sell them up to an Nvme Drive because it's faster, right? But people need to fall in love with the drive again. This is a passion for me. And the technology is out there for all of us to go faster. It just takes the desire for it too. So if anything from this week, please fall in love with drives. Get a RAM drive, do a RAID, scare your IT manager. Let's have some fun breaking computer down. Yeah.
Exactly.
I haven't played with RAM drives in a while. I think I'm gonna get back to that. It's been about a year since I've tried RAM drives again.
Nice.
So I mean, if you want to just keep it simple though, and you got money, just go Optane. NVMe drives have gone down a lot though. So if you got money but not Optane money, NVMe drives are the sweet spot right now.
Right.
But I'd rather have capacity over speed. Like if I could only afford a 250 gigabyte NVMe drive, I'd probably just go normal SSD, because that would get you about a 500 to 1 terabyte SSD. At least get a 500 gigabyte OS drive, guys.
Right.
I was in Revit forum online, and there was a user complaining that their IT department was literally using 120 gigabyte SSDs for their workstations, so users couldn't install extra stuff.
Right.
I'm like, oh my gosh. Please have enough.
Yeah.
That's bad practices.
Right.
Yeah, we did an article with the MCAA, and we did a ton of benchmarking on drive speeds and the ROI of drives. And drives are one of those things that the ROI is there. I mean, if you have a spinning drive, you should be easily able to convince to get an SSD. I mean, when we talk about the price of these drives, you can get a 250 gigabyte non-NVMe SSD for $120. I mean, they have some for $90.
No, man.
When we're talking
the last year, they've gone down.
Yeah, $256 for a 500 gigabyte. A 1 terabyte 970 Pro is $680, something around that range. If you have an expensive CPU, and this is my rule of thumb, you should spend the same thing on your drive as you do on your CPU. If you have a $2,000 18 core, get 2 Optane drives, rate them out, have fun, right? If you have a $450, $500 9900K, you should have a 1 terabyte or a 2 terabyte or even 2 500 gigabyte 970 drives. I mean, there's a correlation there, and we always like to think, what should we spend on it? I mean, I think our architects and whatnot out here, right? If you're spending $300 a square foot, there is a calculation of what you should spend on interiors, right? There is a calculation of what structure should be. And I think the computer is no different. We should have those ratios in here, and that should be something we track I know internally when we build systems, we track that stuff. You know, how much are we spending on our graphics cards compared to our motherboard? And it all should be relative, because you can get away from that. I think we see a lot of times someone says, like, I like an XP, and then you're like, what are you running? They're like, I don't even know who SSD, and it's like, you spend too much on your graphics card. Like, you were missing out. So
the other,
you know, I think, yeah.
The other thing to consider too is, like, sometimes people get worked up over how much certain things cost, but like a video card that you might spend $600, $1,200. Some of the guys going Quadro, they're spending like $5,000 on their video cards. That's going to be essentially obsolete in 2 years. But your SSD or your NVMe or Optane, whatever your storage is, technology's been moving so much slower that I feel it's a better investment to get the bones of a computer squared away, because you'll just have a longer life cycle with that product. Whereas a new, like, RTX cards came out. Now all of a sudden we have real-time ray tracing cores. Software is going to suddenly slowly start developing for that. And now it's like, well, I have a 1080 Ti, it's last generation. Well, yeah, Enscape may have just updated their software, and now these $500 cards are smoking your $1,000 card. So, but with storage, when you invest in storage, it's like, you won't need to worry about it. You're already squared away. You got the best you could afford, and you could just worry about the fun upgrades like video cards and stuff.
Well, and to be a curmudgeon, to be an absolute curmudgeon, because I am a drive nut. I was so disappointed with Intel when they came out with the first series of Optane, which, for anybody that knew, it looked like the Nvme Drive. Look, this was like 6 years in the making. Optane's coming, 3x point. I'm like watching videos, drooling. I'm pre-ordering. I'm like a ton of them. I'm gonna try to rate them out, and it comes out, and I put it in a computer, and I find out it's supposed to accelerate spinning drives for gamers in low-cost systems. So literally,
we still have some.
We do. Ask Anthony. We have a bunch of it on the shelf from the day I bought it that we never found a use case for. Right? It was.
They don't even let you raid them.
You can't. We put them in our RAID drives, try to raid them out.
This is first edition, by the way, everybody. First edition.
First edition. Correct. But so you put them in your computer, and it would serve as the cache for your spinning drive. So if you have a $40 spinning drive, you can spend $30 on Optane. I was like, Intel has spent 6 years and who knows how many millions of dollars to speed up spinning drives. I'm sorry, I was losing it. So drives are going slower. And if you think about it, you have Intel and Samsung are the only real two players in this game for high performance. I have personally seen at a convention NVMe Drive, it was 960 at the time, that had 25 terabytes of storage. Samsung can do anything under the sun. It's almost like Intel when AMD releases a new card. They brush off the dust on the old technology. But until us as consumers, until we decide we want faster drives, a spinning drive works, an SSD works, and why is Samsung going to release the next gen, lightning fast thing for us? They're in data centers. I mean, every time we're using, Google or anything, they have the advanced stuff. But until people become drive nuts, until we start demanding more, we're not going to get anything more than we have right now. And that's just hard. I wrote a horrible article and I blasted Intel. And then, like Anthony says, that was Gen 1. Now they've come out with a fast one and we love it. So I'll be honest, they came around. But the drive technology, this is one of those things you're never going to worry about next year. The lightning fast drive is released, right? So that's all I'm worried. All
right. Well, guys, we're coming up on the end of the time. Any final closing thoughts for 60 seconds?
This isn't drive related, but I would like to know what people might think about. Buck and I talked about this. We could shove an 18-core processor in this. I mean, would someone like something like this for cloud processing in the field?
Dude,
or point cloud processing?
That's like half the size of a minute.
You saw that's half that.
What's that?
Yeah, I mean,
this is a
yeah.
I don't know if this is showing up. This is a dual Xeon system, and you could have this in the field with 18 cores.
Right.
I'm just curious what people might think about that.
I want that computer. That thing's awesome.
Can I put toast in it? It looks like a little toaster.
Yeah, it kind of does look like a toaster at this angle, doesn't it?
There we go. Well, it'd probably it'd be exhausting so much hot air. You could probably toast some bread on there too.
You probably cook an egg over that thing. No.
Yeah.
Well,
cool.
I'm glad Anthony showed that. This is something we're looking at to get rid of the laptops in the field doing point cloud processing. Put an 18 core in there, load it up with drives, and let someone be able to drop that in their backpack, take it out to the field, and just shred. You could have as much RAM as you want in there. It's cool. It's got water cooling. And we're trying to be mindful of that, man. I mean, I think the biggest thing, if there's anyone listening that does point cloud processing on laptops, just get more RAM, get the fastest drive you can get. It will speed up whatever you're doing right now.
Yep. Fantastic. All right, guys. Thank you for your time today. I'm looking forward to seeing you guys on the next show where we're going to be talking about what is next. Is it, I forget, graphics cards?
No idea.
Graphics cards next, I think so.
Yeah, let's go graphics cards.
That might have been it. That might have been it, yeah.
All right, so in 2 weeks on Friday at lunchtime, Central Time, 12 Central, we're going to be talking graphics cards next round.
Oh, and the giveaway.
Good.
Oh, right.
I think we're going to do 4 today. Anthony, we have 4 Octane drives, right?
What? Hang on to those, man. Jeez,
Gen 1.
We got a couple more shows yet. Jeez.
The Gen 1.
I had a...
Oh, Gen 1.
No.
You have a spinning drive out there. Accelerate it.
All right. This is what we'll do.
If you have a spinning...
Okay, if you got a spinning drive,
no one's gonna enter.
Octane, you let us know what the specs of your spinning drive are, and we'll hook you up with the Gen 1 Octane as an accelerator to your mechanical spinning hard drive.
I mean, they're Gen 2
yeah, keep in mind this is most likely going to be for experimental use if someone wants to geek out and play with it.
Right.
I'm sure we got plenty of nerds out there, so.
Sure.
Oh man, yeah.
Good times.
4 people. We got 4.
4
It'll
people. So the way this is going to work, if you've commented to us in the show notes today, if you were on live, we got Rob and Matt already entered for that. Hey, we got Remus Computer Solutions in the mix as well there, Anthony.
Oh yeah, no, that's me. I was trying to see if there was any interaction, and I'm like, oh, I'll chime in and chat, but today was a quiet chat feed.
But so we got those 2 already entered, but if you leave us comments in the YouTube video about the mechanical hard drive woes you've been going through, then you'll be entered to win one of those 4 Gen 1 Octanes.
I was hoping we were going to give something like a computer away so I could enter to win as my other account, but let me retract that comment.
Yeah, right.
No, it's fun to play with. It actually does work really well for spinning drives. I mean, there's no doubt about it. It was just a confusing product when it launched, because SSD prices were already cheaper. Right. But it's fun to play with. Someone might have an HD PC, they want to throw it in.
Sure.
It's
I guarantee you, there's someone out there that will speed your computer up. I promise you. I promise you that if you drop it in. And even if you think about it, for the point cloud folks that have a big, 4 terabyte spinning drive, you drop this in, this will serve great cache for that.
To help you do that.
There are use cases. We
the
don't
laptop users. The laptop users out there. Because I don't know why every laptop still comes with a spinning drive unless you're spending like $1,000.
Right.
And a lot of these new ones do have M.2 ports, and so actually our laptop users out there might benefit from that.
All right.
Yeah.
All right.
Awesome.
Well, that's what we got for this week. We look forward to seeing y'all on the next show. And so sign in live for chances to win. Hey, Matthew's still here. Hey, Matt. So we'll catch you guys all later. Thank you so much.
All right, thanks, guys.
Till next time. See ya.